Hi, welcome to the garage. I'm David Schoneman. Have you ever wondered about taking a pile of rusty, old, vintage motorcycle parts like this and making them into something like this? We're going to show you how. Stay with us. Hi, welcome back to the garage. We're well on our way building our vintage BMW Roadster out of a pile of old rusty parts here in the shop. And we've got a lot of parts on order. Some parts have been coming in. And now we're starting to take a look at where we're going to put all the equipment, electronics in particular, that need to go onto this bike so that it can run. I've got the frame up here on the bench again. And normally when I've had the frame on the bench, I've had it oriented this way, where the front of the bike is this way. Today it's the opposite direction. And we're going to be looking at where to put things on the frame. So I've turned it around so that we get a better view of this side of the frame. As we build the bike, there's a number of things that have to go in various places. We have a battery, we have voltage regulator, we have coils, we have all kinds of things that have to go somewhere. And one of our objectives on building the bike is to keep this section of the bike very clean. And by clean, I mean mostly empty. You know, the engine's going to be here. And when we saw the bikes in the first episode, you noticed, if you did notice, that we had the engine, of course, in the frame, but this section of the frame was open. And that gives it a very clean look. It tends to showcase the motor, because by having nothing here, your attention is not drawn here. It's drawn to the engine. And that's what we want to do. We want to draw attention to the engine, to the beautiful carburetors we're going to have, to the bright red tank. We don't want any distraction in various pieces of equipment hanging around. So in order to put things where they're not going to be visible, we have to have room. And what I try to do is to put as much under the tank as I can. So we're going to take a look today at what needs to go on the bike and where I might put it under the tank, how we're going to accomplish that. First thing, we've had the tank on the bike before, and you've seen that before, but it's just been setting on here. It's not been in position because we didn't have the mounting hardware for the tank. Now we have the mounting hardware. In the back here, at the back end of the tank, there's some rubber bumpers that support the tank, so the tank is now going to be about that much higher than it was when we had it on the frame before. And up front here, there's just a metal tube welded to the frame, and we ordered this rubber bumper. It's a stock BMW part. It fits over here, and it provides cushioning for the tank. So we'll have the tank supported in the front. This tube here on the tank is going to wrap around this rubber cushion here, and the back part of the tank will sit on those. So let me set it in place, and we'll talk about what we have. Actually, before I do that, I want to show you something. Under the tank, typically we have a tunnel. It's called the tunnel. And the tunnel is just space under the tank to accommodate this section of the frame. Now, most tanks, or many tanks, are symmetrical in the shape of the tunnel. This one is not. It's kind of interesting. This seam here, if you can see it, this seam right down the middle of the tank, this will be right over this metal tube on the frame. So you can see that there's more room on this side under the tank than there is on this side. This is the right side of the tank. This is the left side of the tank. There are certain cutouts here. There's a big opening up here. There's a little space here. There's more space here, but a lot of space on this side. So if we set the tank in place, this is in the actual location it'll be in. It's in position. We can take a look under the tank and see what kind of room we have. And I've done some of that. I've measured the amount of room we have from the frame member over to the inside of the tunnel on this side. We can look down here, and you can't see it. I'm sorry you can't see it on the video, but there is space, and there's a lot of space on this side. So we got room to put things here on the right, not on the left side so much. So we'll take the tank off, and we'll talk about some of the things we have to place. you can see a mounting point here. There's two screws, two nuts in here. There's two on the opposite side too. This space here is made to hold the coils. These are the Bosch coils that would have come with this bike. They clamp on here, one on this side and one on this side. And we have spark plug wires that run and various connections to the coils. They take up a fair amount of room. There's another alternative, and we're going to go with a different alternative. Instead of using two coils, like would have come with the BMW originally, again, there's two cylinders, so we need to have two spark plug wires. Instead of having two single coils, we're going to go with a good aftermarket double coil. This is a Dyna coil. It's mounted in a bracket here to go onto the bike, but it's a single unit that has provision for two spark plug wires. So instead of using two coils, we're going to use one coil with 2 points of contact for the spark plugs. So I just put a spark plug wire on here. Probably not going to use this one, but this is just to allow us to make sure that we can route the wires appropriately. So I'm going to use the same mounting point that we had originally. So I've got a screw here. I'm just going to screw this in. So we begin to take a look at what goes where. Now there would be another screw here to hold the other bracket. I'm just going to put one screw in for now. And if we were to put the tank on, in the present position, I did this earlier, so I know how it works. But if we put the tank on now, the coil will protrude below the line of the tank a little bit. And I want to have as little visible below the line of the tank, the bottom edge, as possible. So what I'm going to do is I'm going to just rotate this bracket a little bit up to about this position. Not much of a change, but it takes the corner of the coil that would otherwise be visible under the tank and tends to tuck it up a little more. Now that's going to necessitate that I enlarge this hole in the bracket in order to use the same mounting point, which I'll do. Easily done. I'll use a file or a Dremel tool or something to enlarge that hole there so that the coil can be held by two screws and held in this position. Now I could have put it on the other side, but I believe that it's better on this side. If it was to be on the other side, there's not room for the wires if they go up. I want the wires to go up. I can mount the coil so that the wires go down, but then you're seeing these protrusions on the coil. And again, I don't want anything to be visible. So I tried both sides. I tried different positions of the coil, and I found that this one works well because there's enough room under that right side of the tank, that tunnel that we talked about, for this wire to kind of arc up and to go out to the cylinder. Again, we're not going to use this particular wire, but the main point is what's happening here. And this wire can arc up underneath the tank without contacting the tank and getting any kind of chafing issues. So we're in good shape with the coil here. Now we have a lot more room here. And what do we want to put here? What else do we have to mount? We have a little space over here and we have space on top. Remember, there was a hump kind of under the tank, and I've marked it here. This is where the hump, that portion that raised under the tank, this is where it begins, and it kind of arcs up like this. So what else do we have to mount? We have a battery. This is the size of the battery that would normally be on this motorcycle, and it's designed to go here. Would mount here in a box, and it's visible. So we want to have the battery not be here. Now, what do we do with this thing? That's a big, heavy battery. On the green BMW that we saw a few weeks ago, the Roadster, that R75, the battery was actually mounted down here, like this, where the center stand would be. That bike has no center stand. And so putting the battery here in place of the center stand was a good option because aside from the orange color, it was black, it kind of blended in, it was not readily visible, and this space could be open. That's one possibility, but on this bike I want to use a center stand. So now we have to find some place to put this big battery rather than here and rather than here. It certainly cannot fit under the tank. So we have some options. This battery has good cranking power, by the way. It's got enough power to easily crank this motor. If we had a kickstart only, we wouldn't need very much power because you're only using the power to help generate a spark. But in this case, we have to generate a spark with the battery, and we also have to crank the engine. So we have lithium-ion batteries. This is anti-gravity battery number 401, a nice tiny battery, 12-volt battery. This has 120 cranking amps. This would be sufficient for a small motorcycle. I don't think that I would use it for one where we're actually cranking a motor. This would be good for a kickstart bike, one of these. These come in various sizes, but I have 3 of these 401s, and I can gang these together. They're very light. I can gang these together to get 360 cranking amps, which is, I don't know how much this one has. This one probably has a lot. Oh no, 220. Cold cranking amps, 220. So this has more. This has more cranking power in this battery, and certainly will be sufficient for the 1000 cc engine that we're building here. And I can gang these together, much like you would have if you had 3 batteries and a flashlight. They're ganged together. Or if you had a car battery that was dead, you hook up a jumper battery to it to get the car to start. So we can gang these together, and they will fit under the tank, something like this. The bottom edge of the tank, I measured, is about it's about 13 inches from this rail. So right about here, here's the bottom edge of the tank, just below this tab. And if we mount batteries here, I can put 2 here and 1 here. They're not as high as the bar. They're not as low as the low point of the tank. And I can wire them together, and we'll have the power we need to get the bike started. So that means I need to make a battery box to support these, and then figure out how to wire them together. I've been working on that. Couple of ideas. What I've done in the past to make a battery box is I've used steel angle like this. I make a couple of rails. Can have batteries here, put another rail over here, and strap them in, and then figure out how to attach the box to the frame. Some considerations for that. How to attach a battery box to the frame. The stock one, it's got tabs welded onto the frame, and then the battery box bolts onto it. I can do that. I may do that. I can build a frame, a box, and then bolt it on. I have to figure out how to put a tab on here and bolt it on. Or I could actually weld the battery box directly to the frame. That would be the strongest, probably the simplest. Can certainly be done. Some considerations, though, when we decide what kind of material to use. We've got aluminum in the shop, and we have steel. This is steel. Steel is weldable. Aluminum is weldable, too. I don't have the equipment for it right at the moment. But I cannot weld aluminum to the steel. So if I make an aluminum battery box, I have to figure out how to bolt it on with some new tabs here. I would weld a tab of steel on here somehow, put a hole in it, put a bolt through, and a nut on the other side. That's one possibility. I think it's more versatile if I make a steel battery box, battery tray, because then if I want to, I can weld the steel to the steel, no trouble, or I could bolt it. And I'll put it together. I'll just tack it together, weld it, tack it together, so that if it's not quite right, we can take it apart and do something different. So my plan is to build a battery tray here to support these 2 batteries. The depth of that tunnel is larger than the depth of 2 batteries. I measured that. We have 3 3/8 inches on the side here, and this is about 3 inches deep. I'm going to put a little bit of Yes, it's just short of 3 inches, actually about 2.8 inches. I've got a room to put a little padding between the 2 batteries and on either side on either outside. And then I've marked the terminals, haven't uncovered the terminals because this is a live battery. I don't want to risk getting any shorts or anything or contact, but I can put the 2 positives. So it's going to be positive to positive to positive, negative to negative to negative. And then this battery will sit over here, and I will do all the connections to the bike through this one battery. This one battery will connect to the other 2. So we'll have cranking power, we'll have good reserve power to run the bike, and I think we'll be in good shape. I've got a voltage regulator to mount somewhere. I don't have the voltage regulator yet, but we have to get a voltage regulator. We have to mount that somewhere because the front of the motor is going to have the alternator. It's going to produce power. That power has to come out to the alternator, out from the alternator to be first rectified. That means taking the AC power from the alternator and converting it to DC power to run the bike. The bike runs on 12 volts DC. So we're going to first convert the alternating current to direct current, and then we have to regulate it so that it stays at 12 volts. On the original bike, there were 2 devices that did that. One is a diode board. This would have sat under the front engine cover. And there would have been a voltage regulator like this. 2 devices. Now, we're going to replace these with a modern device, and we can get what's called a reg-rec. It's a regulator and rectifier in one unit, and it's a little more elegant. It's lightweight like these are. But we don't need as much of a footprint. We have a smaller space. Now, the regulator rectifier will have cooling fins on it. Now, the cooling fins are designed, again, this is not the one we're going to use. This is just an example for size. The regulator rectifier will have cooling fins on it. It needs to have some airflow, ideally. We don't want to tuck it way under something where there's no airflow because it could get warm. So our seat is going to go here, and I'm anticipating that we'll take the regulator rectifier, which is about this size, with some cables coming out of it, and probably mount it here underneath the seat. You won't really see it from the side view. On the Moto Guzzi I showed you before, we have the same electrical system, by the way, on that Moto Guzzi as we have on this bike. So we had the alternator up front, and we had the regulator rectifier placed here. And when I showed you the video, we saw the bike in the video, you couldn't see it unless you really, really looked for it. So that'll be tucked under here. The wires can go forward to connect to wherever they have to connect, up here to the battery and to the alternator. So that'll be tucked away out of sight. We're, again, maintaining a nice, clean profile here. And we won't need this box at all because the 2 functions, regulator and rectifier, will be combined in one unit. Next, we have the electronic ignition. Now, in the last episode, we opened some boxes, and I said we received the electronic ignition. Electronic ignition is composed of a few parts. One, it goes on the front of the alternator. That's a pickup. It senses where the crankshaft is, and it's spinning, and it knows when to send a message, electronic message, for there to be a spark sent to the cylinders. The other component is this component. This is the controller, or the module, it's sometimes called. All of the brains of electronic ignition are in here. So this has to go somewhere. Now, we already have batteries here. We're going to have batteries here. We can't stick it here. I'm thinking about using, there's enough room on the other side here. There's a bracket here on the other side. I can mount this right here. There's enough room for it to fit. So again, that's under the tank. It's not at the back of the motor where it's going to be the hottest. It's more towards the front. There can be some cooling that comes through. And it's in close proximity to the trigger. That'll be down here on the front of the alternator. And then we can send the message to the coil for when it's going to send the spark. So this is part of the electronic ignition. The bike did not have electronic ignition to begin with. This is a more efficient, in many ways more reliable unit, and it's certainly smaller. So we're going to replace the points system that would have been up front here with electronic ignition, increase our reliability, have an effect possibly on increasing power, certainly reducing maintenance. And we're going to mount that up here under the tank. Like I said, there's enough room in this little cutout right here. Again, this is the right side of the tank. That's where the batteries are going to go, where the coil is back here. And this little cutout on the tank here is where we're going to nestle the electronic ignition module. And this can be held on with Velcro. They supply this. I can put a plate on here, put one piece of Velcro on the plate, another piece on here, and it will hold it quite securely. It's a very lightweight unit, and the Velcro here that we use is actually pretty strong. Okay, we're going to do one more unit, one more piece of equipment on this bike that was not on the original. We don't have, well, we might have a wiring harness, but the wiring harness and the switches on the bike are vintage and dated. And there's a very nice device, a system of devices from a company called Moto Gadget in Germany that enable us to rewire the bike in a very simple way. But it requires use of what's called the M unit. M for Moto Gadget. The M unit has to go somewhere on the bike, and all of our wires are going to connect in here. So we're going to have wires under the tank, and we need to put this piece somewhere as well. Ideally, you want it to be far away from the coils. You want it to be more than this distance, like from here to here. There's not quite enough room, but in reality, in testing, we haven't seen any issue with the M unit being too close to the coils. There's a potential for some interference because there's a lot of voltage going through this wire when the spark is being made and sent to the cylinder. And if this wire is too close, theoretically, it can, that electrical field nearby can have an effect on the M unit. But in reality, we haven't seen that, so it's possible to mount it closer than the minimum distance that the manufacturer recommends. In which case, we're going to have to do that here. So I'm thinking about putting this one up here. We got a round tube, and we got two mounting points. It just rests on these 2 points. These two mounting points are slightly raised from the base, so it doesn't rest on this plastic base. It actually just rests on these 2 points. And we've got a couple of ways we can mount this here. It'll sit up here, and there's enough room. I already tested this too. Enough room in this hollowed out portion of the tank. This is what I call the hump. The bar comes up here. This top bar, the clearance between this bar and this part of the tank is pretty small, maybe 1/4 of an inch, very tight. But then this portion of the tank opens up, and this piece can sit on top of the bar and sit up in here like this, facing up towards the top of the tank, and there's enough room to connect all the wires. So all the wires and everything will be connected. The last thing we'll do then is put the tank on over it. So we've got a couple of ways we can mount this on here. Again, with only 2 mounting points, we don't need to have a wide bracket. This being a curved tube, it's kind of oval shaped in cross section. The tightest curve is on the top and the bottom. I can drill a hole and put in, it's like a pop rivet, but it's got threads on the inside. Can't think of the name of it right now, what the term is, but I'll show it to you when the time comes. We would drill a hole, put in a pop rivet, aluminum pop rivet, which has threads on the inside, 5mm threads, and then we can run our bolt down through here, screw it directly into the frame. It's not going to be a lot of torque on it. It's a steel bolt into an aluminum fitting. It'll hold, no problem. We have one in the front, one in the back. Our batteries will be right here. This will be the battery that we connect all the systems to, and we can run the cables here as necessary. So this is the brains of the electronic system, as far as commanding when we're going to start the bike and turn signals and horn and all those lights, all that stuff, all run through here. And about the only thing that's left to fit underneath here would be a horn. And we can do a couple of options on the horn. We can mount a horn under the tank so that it's not even visible, or we can get a vintage style horn which has some chrome on it. That's kind of cool looking. It could fit here. It's a BMW product, and it would enable the horn to be heard the best. We can put a tiny horn up here, a large horn down here. I'm going to have to check and see. The small horn is only about $10 or $12, very inexpensive. The large one could be more. And then it's going to be a choice of aesthetics and cost benefit. Do I want to have a large chrome horn that looks good, or something smaller that's less expensive but hidden? Again, it'd be cleaner without it, and maybe we'll go for clean on this bike. So those are the things we need to put under the tank, and those are the major electronic components that we have, and they'll all fit. So what I'm going to do is I'm going to begin, I'll clear the bench off in a moment, and I'm going to start measuring and cutting some of this angle to make the battery tray, and I'll show you how we do that. Also, before we go in this segment, I want to talk a little bit about the seat frame here. The seat frame, again, it's just sitting here. I'm not 100% sure what I want to do with the seat frame. I may shorten this a little bit. I'm not sure, but we do have tabs that are here for the battery tray on the frame, this point, and down here. So in order to make this as clean as possible, I think what I want to do is, since we're not going to use the battery tray here, is cut these tabs off. So I can get an angle grinder. I think I'll cut these two tabs off, one on each side. Then I'll put a sanding disc on it, a flap disc, very powerful flap disc on an angle grinder. I'll show you. And then we can sand this metal off here so it'll be smooth. It'll look like this tube. It'll look as if it's never been there. So that will, again, improve the aesthetic cleanliness, or how clean it looks when it's all done. Same with this frame down here. It's a little hard to see, but there is a frame member that runs across between the left and right sides, and there's a bracket here that would hold the battery. So I'll cut that off with the angle grinder, cutting disc, and then clean it up. All this is going to be done before we get the frame to the sandblaster. Then on the seat frame itself, we've got some wire tabs here. These are just little bendable tabs where you can tuck a wire or something in place. Or maybe it's for the side covers. There would have been side covers here. We're not going to use the side covers either. It's just going to be open. So I'll cut those off as well. And then, like I said, we're going to figure out what to do with the seat. Do I shorten the seat? Do I leave it the same length? Do I put a little turn up on the end of it here? I'm not 100% sure on that. So that's our consideration of where things are going to go. It's very important as you're planning this out. You don't want to be building a bike and then say, holy cow, where am I going to put the battery? We don't want that to happen. So we got to plan these things out in advance. And we do that with an idea of what we're trying to accomplish with the bike. And again, for this bike, we're trying to accomplish a very clean look. I want to emphasize the motor. I want to showcase the tank, and want to have a roadster that's just super clean looking. And that's accomplished by putting as much under the tank as we can. Same thing we did with that Moto Guzzi. I don't know if you remember seeing that, or go back to that first episode and check it out. The portion under the frame was very, very clean. There's nothing there. And with that motorcycle, just like this one, everything was tucked up under the tank. And there are equipment, things that we can do that make that easier. The electronic box, very small. Electronic ignition module, very small. And we can use these lithium-ion, lightweight, tiny batteries. I've never ganged batteries together, by the way. These batteries come in different sizes. I can get one that's about this size and twice the power. These are called 401s. That would be an 801. And 801, it's sufficient for the Moto Guzzi. That's what I have in there. But with this motor being bigger, I think I want to have a third battery. And if we buy one that's manufactured that way, it's going to be larger and bulkier. But this gives us the option to put them anywhere we want. I can line 3 of them up in a row. I'm essentially building my own battery. So we'll do that. And I'll get the tools out. We'll start measuring and cutting for our battery tray in just a moment. Okay, we're back, and I'm starting to make the battery tray that we talked about just a moment ago. A couple ways to design this. First off, there's the easy way and the more difficult way. This piece, it's structural in that it's going to hold the batteries. The batteries are not super heavy. The material that we're using is 1/8 inch thick steel angle, and that's plenty strong for the lightweight that we have here. This piece is not going to be visible. It doesn't need to be super pretty. And it's no more structural than what I already described. So 3 ways to design it. One is we could do it on some kind of computer system, which I don't have. We don't have that in the shop here. I can use a pad of paper, which I've certainly done before, where I take measurements and angles and all that sort of stuff. That would more typically be done if I'm making something that's going to be visible. I want to make sure everything is just right. Or we can just fit things together on the bench. And right now, today, we're just going to fit things together on the bench. I've talked about how the batteries are going to go into the tray. We're going to have 2 batteries. Now, I'm working from my right. So remember, the bike was the other way around. 2 batteries towards the front of the bike, my right, and then 1 battery next to it. I've got some angle set up here. It's 3/4 inch by 3/4 inch steel angle, 1/8 inch thick. I'm not going to miter the corners or anything like that, like a carpenter would for doing finished carpentry. I'm just going to fit them together so that it'll look like that, just a square edge. And to do that, I'm going to just set things down, put them in place with pads that I'm going to use. This is about 1/8 inch thick foam pad. I want to cushion the battery away from the metal, that far on one side and that far on the other side, and the same between the batteries. So I took the pack apart here and I put in 2 little foam strips that will make it the right size. I want to have a piece of foam on the edge, on the end. So I'm going to set this assembly right in here like this. This is how it's going to go together. Everything is touching properly. I'm going to put a piece of foam between the batteries here, just like it will be when it's made. And now I know how long I need to make this. I'm going to have a piece of foam on the end, and I basically want the vertical piece of the angle over here, because that's 3/4 inch of long, to be, I want to make a cut 3/4 inch from this edge. So I can measure here. And it's okay to have a little bit extra. I don't want to have a lot extra, but it's okay to have a little bit extra. I've got a mark here that's, this is about 5/8. Right there, that's about 3/4. We don't want it to be too short. So I've got 2 marks here, 5/8 and 3/4. I'll make sure that I leave the mark that shows at 3/4. So I set these aside, and I can put this into my saw. I've got a DeWalt metal cutting chop saw here with a fiber type blade. I can clamp this into place. I'm not going to start the saw up until I get my goggles on. Just setting the distance properly. This has a kerf. A kerf is the thickness of the cut. This has a kerf of about 1/8 of an inch. And again, a little bit longer is okay. A little bit too short, no matter how many times I cut it again, if it's too short the first time, it's going to be too short the second time. So we'll just give ourselves a little bit extra. I don't see any harm in doing that. I think we have the room under the tank to accomplish that. All right, that looks good. Always use safety glasses when you're cutting metal. The sparks that fly out from this thing it's molten metal. It's red hot metal. And one time I got a piece caught in my eye, and it's not pretty. Fortunately, our eyes heal very well, but it's always wise to wear goggles. So we're going to wear goggles, safety glasses here, and we're going to cut this. All right, we've got our piece. Let's check the length. Make sure this is correct. We can use this piece too, just to line everything up. A couple of scrap pieces that work well for this purpose. and we're good. We've got probably about 1/8 of an inch extra. Our piece of pad fits in there nicely. The length is good. Everything is cushioned properly. Okay, so that's one piece cut. Now I'm going to take a piece of angle and I'm going to set up on the back side. It's the same thing. Now how long does this piece have to be? This piece is going to be shorter because I only have to hold the 2 batteries in this section. I'm not going to make a tray all the way out here. I'm contemplating making a tray that's narrow where the 1 battery is and wide where the other battery is, where the 2 batteries are. So I've just got my pieces in place. We're just going for length at this point. So I'm going to measure if I had a pad here, I'm going about 1/2 inch. Maybe 5/8 like last time. Right about there. Again, it doesn't hurt if it's a little bit long. You can always shorten it. That will work. Now we need a small piece. Actually, we need to make the piece that's going to go over here. We'll have to figure out exactly how to do this. I'm just going to cut a little piece off of here. Knowing that we're going to fit all this together. We can always grind it down a little bit if things aren't exactly right. Again, we're just kind of rough fitting this. Maybe we'll get this piece cut first. I want the end to be at about the same place as it will be here. Okay, I know what I want to do. Right there, even with that, and even here. Okay, again, this is going together very simply. We're not spending a lot of time designing things. I need to make two pieces. One is going to go here. It's going to be about this length. You can always trim this down later as need be. Right about here. To make our box. The steel, by the way, you can find it. I buy some steel online, a place called Online Metals. Great, they got a lot of variety, and the prices are pretty good. Shipping's not bad either if you shop carefully. Or we can go to Home Depot, and some of the steel is available at Home Depot. A little more expensive, but they have what you need, and you don't have to wait for it to be shipped in. It's a little warm. And we got two more pieces to make. Then we'll final size it and we'll get the welder out. We'll tack it together. Really, we're just looking for length on the side piece at this point. That distance is right there. That'll work. And one piece left. I've been using this piece of scrap over here. We're not using this piece of metal. We're just going to be using a piece like this. Holy cow, that's just about the right size. Well, there we are. I'm going to have a tray. I'm going to do some cutting, some more cutting and grinding to get rid of this little angle here to make sure everything fits properly. But essentially, we've got our box, our battery box here. And if you can see it, we got two tray rails, a space for two batteries here, and one here. I'm going to clean up all of these corners and whatnot, and I'm going to weld it in the meantime. And then when we come back for our next episode, I'll show you our completed battery tray. And then from there, I'm going to weld on some tabs to put a battery strap to hold the batteries in place. And then we'll have to figure out how we're going to mount this tray on the frame under the tank. And of course, we're going to double check for size too, but I think we're in good shape. I'm just going to tack it together so that if we have to take it apart to change something, I can easily cut it and take it apart before we do the final welding. So we'll clean it up, grind down the burrs, tack it together, and see how it looks, and I'll show it to you next time. Thanks for watching. Hope you're enjoying the show. If you do, please hit the like button down below. We have our own YouTube channel now. We've been showing it via the TV station's YouTube channel, but we have our own at Milliard Moto. So if you search on YouTube, you find Milliard Moto, you look for Schoneman's Garage. We'll have all the episodes there. If you're watching it on TV or looking at Channel 96 here in Nashua, thank you for tuning in. And if you're seeing it on YouTube, of course, like we've said before with the TV station, thanks for watching there. And we're also going out on Roku, so you can look us up there as well. Hit the like button, subscribe, and come back to watch next time. And we'll see you next time. Thanks for watching.